All right, thank you for joining us today. And in this video, we are going to talk about local extrema, increasing and decreasing using the sign chart, right? Critical values and the rest, right? We have like different functions, like 6 of them. But before we start, I just want to give you some information, the procedures whenever you are doing it. So first, if we are talking about local max, right? So local max is the x value that maximizes the function, right? And then local minimum is also the x value that minimizes the function. So with local max, mostly on the sign chart, you are going to see something like plus, minus, right? Plus and minus. And then on the graph or on the sign chart, you're going to see something like minus and then plus, right? So whenever you see plus, or let me say, or you can see something like increasing and then followed by decreasing. That value in between that is what is going to give us the local max, right? And then you can also see something like decreasing and then increasing. So whenever it's decreasing, we are using the minus, and whenever it is also increasing, we are using the positive. So this is the idea. Now, for us to look for the x values, we need something called critical values, right? So we need critical values. Now, critical values are the values that are the values of x that make sure that f prime is equal to 0, right? So anytime f prime is equal to 0, this helps us to find the critical values, right? So this helps us to find the critical values. So let's talk about critical values. So critical values, they are values when you plug it in the f prime, you get 0, or let's say sometimes undefined. But here we are going to focus on when it is equal to what? 0, right? So it means that for us to find the critical values, which is the x values, we need to differentiate the function and set it to 0. So if the function given to you is like y, then y prime should be equal to 0. So that is the idea with the critical values. Now, after you are done finding the critical values, the next thing that you need to do is the sign chart, right? So on the sign chart, that is where if we assume that A is less than B, then we are going to have something like A here, B here. Then we check if this one is positive, it means that it's going to increase. If this one is negative, going to decrease. If this one is, let's say, also positive, and is going to also increase. So looking at the idea that I gave you here, you can see plus, minus, and the value in between this is A. So it means that at x is equal to A, this is going to give us the local maximum. And you can see how the graph is going to be. So we have increase, decrease. And then at B, that is where we have the minus and then the positive. So minus, positive, where decreasing and increasing, forming a minimum. So this is what is going to give us the local minimum. We have some other cases where we don't have maximum and we don't have minimum. For example, if I have a graph which goes like A, B, here is minus, minus, minus. You see, all of them are minus. So there is no local extrema, right? If we have positive, 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 this one too, there is no local extrema. We have some instances where you can also have positive, minus, positive, and you can see that this one here is going to give us the minimum. So it means that, and then this one here is going to give us the maximum. But let's assume that this is minus. So minus, minus, positive. So we have just only minus and positive, which is going to give us the minimum, right? So there is no maximum here. And then we have some instances where we have positive here, and this one's also positive. So, or let me say this one is positive, this one is minus, and this one too is minus. So with this one, we have maximum, but we don't have what? Minimum. Right. So let's go through the questions, and then we use the idea that we've just learned, right? So first, differentiate the function, set it to 0, look for all your critical values. Then when you are done finding your critical values, you use the sign chart to what? Look for the local maximum and then local minimum. Don't forget, with increasing and decreasing, we can use the idea of this to determine the increasing and decreasing what? Interval. Let's start. So if I have y to be equal to this, then what is y prime? First, that's what I need. I need the critical values. So y prime will be equal to, when I differentiate x to the power 3, what am I going to get? 3, I'm going to get 3x squared, right? Plus, when I differentiate 9x squared, what am I going to get? 2x minus 0. So when I simplify, I'm going to have 3x squared plus 18x. This is what I'm going to get. So I need to see if I can do some factorization so that I can see it very well. So here I can see that 3 can divide 18. So it means I can factor 3 out. I can see x here, so I can also factor x out. So it will be left with x plus 3 divide 18, 6. So this is what we are going to get. So from here, we can see that when x is 0, this function will be 0. That's what we are looking for, because we are looking for the idea that for critical values, y prime should be equal to 0. So when this one is 0, this one goes to 0. We can also see that when x is equal to minus 6, this one too is going to give us 0. So our critical values are going to be s is equal to 0 and x is equal to minus 6. Other way of seeing this is you can just pick this one to be equal to 0, and then 3x will be equal to 0 and x will be equal to 0. Like dividing through by 3, you get x equal to 0. And then you can also pick x plus 6 to be equal to 0, then x is equal to minus 6, which gives you the same thing here, right? So that is the idea of doing this. So these are the x is equal to 0, s is equal to minus 3 are the what? The critical values. So critical values for x. So x is equal to 0, s is equal to minus 6. So now that we've gotten our critical values, now we need the next thing that we need the sign chart. So the sign chart goes like, so as I said, a should be less than b, so that a can come first. So the least value here is minus 6. So we are going to have minus 6 and 0. So what we are going to do is we are going to pick some value here, then we test it. We pick any value here, then we test it. We pick another value here and we test it. Something that I didn't mention, anytime you are using the sign chart for local maximum and minimum, you need to use the derivative function, right? So here we are going to use the derivative function, which is y prime, which is equal to 3x x plus 6. So that's what we are going to use. All right. So what can we do here again? What we are going to do is we are going to pick any value here, here, and here. So what can we pick from here? Can pick 7, right? So let me assume that this y prime here is the same as f prime of x, so that I can plug it in. So I'm looking for f prime of -7 because that is what is here. I'm also looking for f prime of 1, which is also in between here. No, 1 is not in between there. -1 will be there. Then I'm looking for f prime of 1. Then checking whether they are greater than 0 or less than 0, right? Good. So let's see what we are going to get. Now let's plug -7 inside this. What are we going to get? So when I plug -7 here, I'm going to have something like 3 times -7 is going to give us -21. Then -7 plus 6 is going to give us -1, which is equal to 21. So you see that this value here is positive and is greater than 0. So this one is like greater than 0, right? So this is greater than 0, meaning that this function here is positive and it's going to what? Increase, right? So we do same by picking the other ones too. So let's look at -1. When I multiply 3 by -1, I get -3. -1 plus 6 will be 5. When I multiply this one, I get -15. -15 is less than 0, meaning that this is minus, and then this is going to, so let me use my red, this is going to decrease, right? Now let's look at when f is, when this one is 1, I'm going to have, so automatically we can see that when I plug in 1, I'm going to get positive, because 1 here will give us positive. So this one will be greater than 0, right? And this is going to be positive, and this one too is going to increase. So what are the maximum and the minimum? So let's look for local max. Let's look for local minimum. So if we are using the technique, plus minus is the one that's going to give us the local max. So plus minus, the value here is -6. So s is equal to -6. And then we have minus plus, so x should be equal to 0. In other idea, we can see that the graph will turn like this and turn like this. So there will be max here and there will be minimum there. So that will be the local maximum and local minimum. What will be the increasing and decreasing interval? So that's the question also asking us from here. So now with the increasing, we look at the one that is positive and moving up. There are two. So you can see that we are moving up from -infinity up to -6. And then we jump from here to this side and come and move from 0 to what? Positive infinity. So for increasing interval, we are going to have -infinity to -6 union from 0 to positive infinity. Then for decreasing interval, we are going to have, so the only place that the function is decreasing is in between this. So we are going to have -6 to 0. That will be the decreasing interval. All right. Now let's look at the b. So you see that the first one was a polynomial function. Let's look at this one. So we need the critical values. So the first thing that we need to do is we need to find f prime. Now what is f prime? This is two functions multiplying. So we are going to use the product rule, right? So the product rule, if you know how to do it straight, you do it straight. If you don't know how to do it straight too, then it means that you need to pick your A and B. So I'll do it straight. When I do it straight first, I'm going to maintain e to the power -1 and differentiate this. Okay, let me choose A and B. So A is equal to x to the power 3, B is equal to e to the power -x. What is A prime? When I differentiate x to the power 3 with respect to x, I'm going to have 3x squared. When I differentiate b, now with an exponential function, if you have checked my videos on derivative, I said maintain the function, multiply it by the derivative of the x, the power, which is -x. So this is the power here. So this is going to give us e to the power -x times -1, because when I differentiate -x, I get -1, and this is going to give us -x. Good. So what I'm going to do is I'm going to multiply this by this plus this by that, or I can start by multiplying this by this and this by this because it's addition. So I'm going to have 3x squared e to the power -x, right? So this times that. Now I'll multiply this by this, then I'll show you something. So plus x to the power 3. Some people, my students they will do it like times minus e minus this. So when you do it like this, it's quite fortunate that for me, I'm seeing that, okay, I'm multiplying this one by this. But if you don't take care, you'll be like, this is s cubed minus this. So for you to be on the safer side, you put this one in what? Parentheses, like this. So that when you simplify that, you are going to get, now there's minus here multiplying this. So we are going to get minus x to the power 3 e to the power minus x. So this is what you are going to get. So you see the way we did the polynomial function, we are trying to factor some functions out and see what we can get. So here we can factor e to the power minus x out, which is true. We can also see x squared here, x squared here. So we can also factor x squared out. So here we'll be left with just 3x. I think so. Is it 3x? No, it will be just left with 3 because I have this one here. I have this one also here. So it will be left with 3 minus I have this one here. When I divide this one by x squared, it will be left with just x. Right. So now let's look for the values that will make this function 0. So when x is equal to 3, this one will be 0. When x is equal to 0, this one will be equal to 0. But we don't have any fixed value for x. When we put it here, it's going to be what? 0. So mostly this one, we are not going to mind this function. So we are going to focus on this. So x squared is equal to 0. It means that x should be 0. 3 minus x should be equal to 0. It means that x should be equal to 3. Right. So that's the idea, because after we've gotten the f prime, we need to make sure that f prime of x is equal to 0 so that we can get the critical values. So now s is equal to 0, s is equal to 3 are the critical values for x, right? So the next thing that we just need to do is we need to draw the sign chart. We have 0, we have 3. So f prime, we can pick -1 because -1 is here. F prime, we can pick 2 because 2 is in there. Then f prime, we can pick 4. So picking -1 here, 2 here, and 4 here, we are going to plug this inside f prime. So don't forget, this is f prime of x. So I can even write it here so that we can just plug them in. E minus x, x squared, 3 minus x. So let's do that. When I plug -1, so -1 here is going to give us e to the power 1. Then -1 squared is going to give us 1. Then 3 minus -1 is going to give us 4. So definitely this is e here is a number, right? Like I think something, I've forgotten, like 1 point something or so. So this is actually going to give us a positive number. You can use the calculator to check and you see that it's going to give us a positive number. So this is going to be greater than 0, right? So like we have positive and it is increasing. Then I pick the 2. So when I plug in 2, now I need to plug in 2. So when I plug in 2, I'm going to have e to the power -2. 2 squared is 4. Then 3 minus 2 is going to give us is it minus? No, 3 minus this one is going to give us 1. But e to the power -2 is a negative value. No, it's also a positive value. So this is also going to give us a positive value. You can check it from your calculator. And everything here is going to give us positive. So this one should also be greater than 0. So this one will be positive and also increasing. So now let's check 4. When x is equal to 4, we are going to have e to the power -4. 4 squared is 16. Then 3 minus 4 is -1. So this is positive. This is positive. When I multiply by negative, it is going to give us negative. So this one should be less than 0. So we are going to have minus, and this is going to decrease. Good. So now let's try and write down the local max, local minimum. Then we look for increasing and also decreasing functions, right? So let's see what you are going to do. So we said anytime we see plus, minus, we have maximum. And then minus, plus, we have the minimum. So anytime you see the same sign repeating itself, it means that nothing is happening there. So this is plus, this is plus. Nothing is happening there. But from here, we see plus and minus, which is like maximum. So it means that we have x is equal to 3, which is going to give us maximum. So since we don't have minus plus, it means that there is no local minimum. So no local minimum, right? So no local minimum. We don't have any x value that will minimize the graph. So that's what you're going to get. Now let's check for increasing interval. Increasing interval. So increasing, we have this and that. So we are going to move from negative infinity up to 0, right? So we move from negative infinity up to 0. Then we move from 0 to 3 because it's still increasing. So union 0 to 3. Now from here going is decreasing. So that one will give us a decreasing interval, right? Decreasing interval, which will be from I think let me see. Decreasing interval should be from 3 to positive infinity. Yeah. So that's what you are going to get at the end of the day. But let's look at something here. We can actually also combine, the whole of this, right? If 0 is like, let's say, we don't know what is happening there, right? So we can also combine this and write it like minus infinity up to 3, which is also true, right? So something like that. All right. So now let's look at the next question. This is also a polynomial function. So let's go through fast. F prime of x will be equal to, when I differentiate this, I'm going to have 6x squared minus 6x. Is it 6x squared? Yes, minus 6x minus 12. So when I do the differentiation, this is what I'm going to get. Now I can factor 6 out so that I have x squared minus x minus 2. Then do factorization. Factors of 2, that when you add, you are going to get minus 1, but when you multiply, you are going to get minus 2. So it means that we can do this one as, this one can be written as x minus 2, x minus 1. No, it should be plus, so that when I multiply this and this, I'll get that. So x times x is x squared. X times this will be x minus 2x minus 2x times this one will going to give us minus 2x plus x, which is going to give us minus x. And then minus 2 times this one is going to give us this. So we should be able to do the factorization there. So this one will give us the idea for us to see that for f prime to be equal to 0, x should be equal to 2 and s should be equal to minus 1. So that when I put 2 here, I get 0. When I put minus 1 here, I get 0. So these are the critical values, right? So since we have the critical values, we go to the line, the sign chart. So minus 1 and 2, the same idea again. Pick f prime of minus 2, f prime of, we can pick 0 here, and then f prime of 3. So let's go through quick. Put minus 2 here. So minus 2 here, this will be minus. Minus 2 here, this one to be minus. Minus minus will be positive. So this one will be greater than 0. Positive, increasing. Put 0 in, 0, 0. And this is going to give us minus, because this and this time this will be minus 2. Minus 2 times this will be minus 12. So it should be less than 0. So this is going to give us minus, and this is going to decrease. Let's look at 3. When I put 3 here, this one will be positive, this one positive. So automatically, this one will be greater than 0, and this one is going to be plus, and this is going to increase. So, now we can look for local max. So at x is equal to plus minus, which is minus 1, right? And then the local minimum is at x is equal to 2, because we have the minus and positive, which is like the graph is turning like this, and then the maximum, the graph is turning like this, right? So let's look at the increasing interval. and then the decreasing interval. So the decreasing interval will be the increasing interval. For the increasing, we have this and that. So we are going to have minus infinity to minus 1 union 2 to positive infinity. So increasing, increasing. Then the decreasing happens between minus 1 and 2. So minus 1 and 2. That will be the decreasing interval. Right. Good. So that is what is going to happen. Now I will leave you with a D for you to try, but okay, let me just go through quick for you to see. So what is f prime of x? This is going to be 12x to the power 3 minus 14 times 3 is going to give us 42x squared minus 90x. And when I differentiate 12, I'm going to get 0, right? So what I can do is first, I can factor 6 out, right? So 6 can go through all of them, I think so, right? So 6 out, it will be left with 2x. Okay, so I can factor 6 out, and then I think I can also factor x out because I have x here, x here, x here. So I can factor x out. So now when I factor this one will be left with 2x squared minus 7x minus 15, right? So when I multiply 6 by this, I'll get this. 6 by this, I get this. 6 by this, I get this. Right. Good. So now the next thing to do is I need to make sure that I factor this. So 2 times 15 will be 30. So factors of 30, that's when I multiply, I'll get minus 30. But when I add, I'm going to get minus 7. So when I do that, I'm going to have 2x plus 3 and then x minus 5. So 2x times this will give us this. This and this will be 10, minus 10, but this will be 3x, which is going to give us minus 7. And then 3 times 5, minus 5 will give us this. So that is right. So now we look for x value that will make f prime 0, right? So the first one that we can see is when 6x is equal to 0, and x will be 0. And when 2x plus 3 is also equal to 0, so 2x minus is equal to minus 3, and s should be equal to 2 over minus 3, right? Then x minus 5 is equal to 0, and x is equal to 5. So this one we had 3 critical values. So when we are drawing the line, which one is the least one? I think okay, this one is supposed to be 3 on 2, minus 3 on 2, followed by 0, followed by 5. Oh, okay, so it's good that I did this one. So here we know that 3 over 2 is like 1 point something. So here we can pick something like minus 2. And then in the middle here, we can pick something like minus 1. And here we can pick something like 1. And here we can pick something like 6. So we have 4 of them. Let's check. Plug negative 2 into this. So negative 2 here will be minus 4 plus this. This is going to give us minus. And then minus 2 here, this is also going to give us minus. And this is also going to give us minus. So minus minus positive. Positive minus will still be minus. So this one should be less than 0. So here is going to be minus and it's going to decrease. Let's plug in minus 1. Minus 1, this will be minus. Minus 1, this will be positive. Minus 1, this one will be negative. So negative, negative will be positive, times positive will be positive. So this one should be greater than 0. This is positive, and this one should increase. So you can use the calculator to do it, but this is how you're supposed to go through. Like now 1, positive, positive, minus. So it means I'm going to be minus because minus multiplying everything going to give us minus. So this one is going to give us minus, and this is supposed to decrease. 6, when I put 6 here, positive, positive, positive. So this is going to be plus, and this is going to increase. Good. So let's look for local max, local minimum, increasing, and then decreasing interval. So what is the local max? Local max is positive, negative, right? So positive, negative, where the graph goes up and drops down. So we have only one positive, negative. We have positive here, but there is no negative followed by. So it happens at x is equal to 0. Now, local minimum, we have negative, positive, which is turning minimum. So x should be equal to minus 3 on 2. But we have another negative, positive again, which is also minimum. So x should be also equal to 5. It's also going to give us that. So what will be the increasing and decreasing interval? So we have increasing, increasing. So this is increasing between this and that. So we are going to have minus 3 over 2, 0, union, or you can use end, but union is better. Then from 5 to positive infinity. So these are the interval where the function is increasing. So from minus 3 on 2 to 3 to 0, and then from 5 going to positive infinity. Then when it's decreasing, we have from negative infinity up to here, and then 1 to which is between 0 and 5. So minus infinity up to negative 3 on 2, union 0 to 5. So that will be the decreasing interval. Let's look at another question. So we have 2 more to go. This one is in the form of fraction. So for us to differentiate, we need to use the idea of, let me say, quotient rule, right? So quotient rule, I'll let this one to be u, this one to be vn. So what is y prime? Y prime is vn u prime minus u vn prime divided by vn squared. So what is my u? U is equal to x. What is my vn? Vn is equal to x minus 3. What is u prime? 1. What is vn prime? Also 1. So let's do substitution. We are going to have vn is x minus 3, u prime is 1, minus u is x, and vn prime is also 1, divided by vn squared. So let's simplify. When I multiply the 1 to this, I'm going to have x minus 3 minus x times 1 is x divided by x minus 3 squared. And I simplify it and I have something like minus 3 divided by x minus 3 squared. So this is y prime. But let's look at this. We want values of x that will make sure that this function here is equal to 0 or undefined. So you saw that with the polynomial function, it's always the case that we are going to get x values that will make the function undefined, right? So here we don't have any x value that will make the function 0, but we have a value that will make the function undefined. So it's also a critical value. So the critical value here is going to be, we are picking the denominator and set it to 0. So this is going to give us 3 minus x minus 3. When I square both sides, when I take square root, this is what I'm going to get, and x is equal to be 3. So this x here is not going to make the function 0, but it's going to make the function undefined, which is also a critical value. So this is a critical value, which is the vertical asymptote, right? It's also a critical value. So now let's draw the line. I have 3 here, right? So let's pick a value here. So let me assume that this is f prime of x. So f prime of 2, f prime of 4. So put 2 here and you are going to get negative, right? Because 2, this is going to be minus 1 squared, which will be 1. Minus 3 divided by 1 is going to give us minus. So this is less than 0. This is minus, and it is what? Decreasing. Let's put 4. 4 here, this one will be positive, but still this is minus. So we are going to have minus and still decreasing. So this is also less than 0. So you see, we have minus, minus. We don't have minus, plus, or plus, minus. So here we can see that there is no local extrema. So no local extrema. We don't have maximum and minimum. We don't have anything like that here. We don't have local maximum. We don't have local minimum, right? Now let's check for increasing and decreasing. Do you have increasing? No, there is no increasing here. The only place that is decreasing is we are decreasing from minus infinity up to 3, and then from 3 to positive infinity. So we are going to have just decreasing interval. So we are going to have minus infinity to 3 union 3 to infinity. I think I made mention that you can combine this. I think, yeah. So maybe because at 3, if you combine at 3, the function is undefined, so you cannot include it. But the other one that we included, it that I was saying that you can include it. Where is it? I think this one. The idea is that at 0, the function is not undefined, right? So we can just include it. So that was the reason why we included it from there. Yeah, so this is what you are going to get at the end of the day. So don't forget, for critical values, is either the function is 0 or undefined. So let's look at the last one, where you will see that we are going to have values that will make the function 0, and then the values too that's going to make the function undefined. So let's use the quotient rule to differentiate this. So f prime of x is ven u prime minus u ven prime divided by ven squared. So you can use f, and it's also the same thing. So u is equal to 4x, ven is equal to x squared plus 1. What is u prime? U prime will be 4. What is ven prime? 2x. So let's do substitution. Ven is x squared plus 1. What is u prime? U prime is 4 minus what is u? 4x, and what is ven prime? 2x divided by ven squared. So what are we going to get? Expand the top, we get 4x squared plus 4 minus 8x squared divided by x squared plus 1 all squared. Simplifying the top, we are going to have minus 4x squared plus 4, right? And then we are going to have, or let me say, 4 minus 4x squared divided by x squared plus 1. And this is the same as when I factor 4 out, I'll have like 1 minus x squared divided by x squared plus 1 all squared. This here is like difference of 2 squares. So I'm going to have something like 4, 1 minus x, 1 plus x divided by x squared plus 1 squared. So we saw that now on the top here we have values of x. Look at this one. This one was just minus 3. So we cannot say that minus 3 is equal to 0. It is not possible, right? So we don't have any value of x that will make the function 0. But when you look at this one, what we are going to do is, since we have x on the top, we are going to pick the top and equate it to 0. So we are going to pick 4, 1 minus x, 1 plus x, and equate it to 0. Then we look for the values that when you plug it in, it's going to give us 0. So here, 1 minus x is equal to 0, x should be equal to 1. 1 plus x is equal to 0, x should be equal to minus 1. So 1 and minus 1 will make the function 0. Now let's go to the down and see if we have real value that will make the down to what? 0. Now we see that any value that we will put it here to make sure that this is going to be 0 is not possible on the real line unless we go to complex, right? But this one, when I put minus 1 squared will make it positive. So there's no way this is going to be 0. So here we don't have anything like a value of x that's going to make this one undefined. So it means that here our critical values are going to be just 1 and negative 1. So let's go to the number line, minus 1 and 1. So what are we going to do? Let's pick the same idea, f prime of minus 2, f prime of 0, then f prime of 2. So let's plug in minus 2 inside our derivative here. So we are interested in the top because the down is always positive. So that's how you can also do things and be fast. So because this one is squared, this one is squared, always the down will be positive. When I plug in minus 2, this one will be minus. When I plug in minus 2, this one too is going to be minus. Minus minus will be positive, right? So it means that at that place, I'm going to have it to be positive, right? So I'm going to have it to be positive. Or let me check. Minus 2 minus no 1 minus will be positive, right? And then this one too is going to be minus, so it's going to be negative, right? So this one should be less than 0. So this one is going to be negative, and we are going to decrease. When I plug in 0, 0 here is going to be positive. So I'm going to have greater than 0, positive, and increasing. Plug in 2. 2 here is going to give us negative. So negative and decreasing. And this is less than 0. So let's try and check what we are going to get. Local max, local minimum, increasing, and then decreasing interval. So local max is plus minus, so we have plus minus. So at this point, right, so we are going to have s equal to 1, and local minimum is minus plus, which is like concave up. So we are going to have x equal to minus 1. So increasing is just this in between minus 1 and 1. So you are going to have minus 1 1, and then the decreasing interval is going to be from minus infinity to minus 1 union from 1 to positive infinity. So that's what we are going to get with that, right? So see, it's very nice. Let's look at the last two questions. I was thinking that's the last questions, but I think another functions are here. So let's go through this last two functions. Now f prime of x, this is going to be the product rule. So let me pick a to be x, b to be equal to x minus 4 to the power 3. A prime. So as I said, always learn how to differentiate individual function and know the rules. So this one is a product rule. So when I differentiate x, I get 1. Now when I'm differentiating b, when I use the product rule and I come to b, the b2, for me to differentiate, I need to use the change rule, right? And if you have looked at my videos on derivative, you know how to do this using the short way. So the short way says that first we need to apply the power rule. So first I'll drop the 3 and then maintain the function, right? Then power rule says that I need to subtract 1. Then the change rule comes in and we need to differentiate what is inside the parentheses, which is x minus 4. So this is going to give us 3x minus 4 to the power squared times, when I differentiate x, I get 1. So this is going to be 3x minus 4 squared. So this is a short way finding the derivative. So now I need to multiply this by this. and then this by this. That will be the product rule. So f prime of x will be equal to, so when I multiply x by this, I'm going to have x times 3x minus 4 squared. Then this time this will be plus 1 times x minus 4 to the power 3. So x, so this one is going to be, I have this one here, I have this one here, so I can factor it out. So I can factor x minus 4 out, right? So when I factor this one out, what will be left? X and 3, so which is the same as 3x. Then this is to the power 3. When I factor squared out, it will be left with plus x minus 4. Right, so when I simplify, I have x minus 4 squared. This is 3x plus x minus 4. Then x minus 4 squared. This is going to give us 4x minus 4. Good. So this is what I'm going to get at the end of the day. Now I see that I can, even this here, I can factor 4 out, but it doesn't matter, right? So what I need to do now is find x value that will make sure that this is equal to 0, right? So I can pick x minus 4 squared and set it to 0. X minus 4 should be 0 and x should be equal to 4. Then I can also pick x minus 4 to be equal to 0. 4x is equal to 4. I divide through by 4 and I'm going to get x to be 1. Very simple. So now let's try and put it on the normal line. 1, 4. Pick f prime of 0. Pick f prime of 2. Pick f prime of 5. Let's put them in. 0 here. Plug it in. 0, 0. This is going to be positive. Positive times negative is going to give us negative. So this is going to give us less than 0, negative, decreasing. Put in 2. So it's, if you don't mind this one, because of this one is squared, because this one is squared, always this is going to be positive. So we need to focus on this, whether we are getting negative or positive. When I plug in 2, this is going to be positive. So I have greater than 0, positive, increasing. When I plug in 3 here, this one will be positive. This one too positive. So I get positive, and this is increasing. So what are the local max and local minimum? We pick these guys up here and talk about local max, local minimum, increasing and decreasing. Right. So what are we going to do? Local max is, we don't have plus minus, so we don't have it, right? No local max. We have minus plus, which is giving us concave up. So we have at s is equal to 1, right? Then what we need to do is we need to look for increasing and decreasing. So for the decreasing, we have from minus infinity up to 1, and for increasing, we have 1 to 4, and 4 union 4 to, let's say, 4 to positive infinity. So that's what we're going to get for the increasing interval. Good. That's what we're going to get for the increasing interval. Let's do the last one. The last question is nice. Should I leave it to you to do it? No. Okay. Here, let me do it. So y prime is going to be equal to product rule. So let me pick my a and b. A is equal to x, b is equal to ln of x. What is a prime? 1. What is b prime? We learn how to differentiate a ln function, but we all know that when I differentiate ln x, I get 1 over x. But what's the process? 1 divided by what is inside the parentheses times the derivative of what is inside the parentheses, which is x. So with that idea, we are going to have something like this. See this one here small. So you are going to have 1 over x times 1, which is equal to 1 over x. So let's do the product rule. This times this times that. So we are going to have x times 1 over x plus ln x times 1. So y prime will be equal to 1 plus ln x. So this one, it's so difficult for us to see if the value of x that is going to give us, that's going to make sure that this is equal to 0. So what we are going to do is, since we need y prime to be 0, we are going to pick 1 is equal to ln of x, 1 plus ln of x equal to 0, then ln of x is equal to minus 1. So ln, which is the natural log, goes with the exponential function. So if you go to the previous video, the derivative videos, you will see that I wrote some notes there, and I gave you that anytime you have something like this, I'm going to pick e to the power x, which is equal to e to the power this. So this here is going to give us what is inside the bracket here. So I'm going to have x to be equal to e to the power minus 1. So when I plug in e to the power minus 1 here, it's going to give us minus 1. So 1 plus minus 1 will make it 0. So this will be our x, which is the critical point. And this one can also be written as 1 over e, right? So on the number line, I have 1 over e. What is 1 over e? 1 over e is like 0.3 something, right? So here I need to pick something like f prime. So if this is equal to f prime of x, I need to pick something like 0.2 because this is 3 point something. Then I need to pick something like um, 0.5 on the right? So when I plug in 0.2 here, this is going to give us negative, right? Which is greater than 1. So it means that this is going to be less than 0. So this is going to be minus, and this one is going to decrease. Good. Then when I put 0.5 in here, it's going to give us either something negative but less than 1, or it's going to give us positive. No, I think it's going to give us negative. You can check it on the calculator, but less than 1. So this is going to be greater than 1 because it's going to be positive. So this will be positive, and this will start increasing, right? So you can see that we have minus, positive. So that one is the local minimum. X is equal to 1 over e. No local max. No local max. And here we have increasing. For increasing interval, we are going to have from 1 over e to positive infinity, and then the decreasing interval, we are going to have minus infinity up to e 1 over e. Wow, wow, wow. So I think this is the end of the video. So that is how we do, that's how we calculate for local extrema. Look for your critical values, which is the idea of differentiating the function and setting it to 0. By looking for values of x that will make the function 0 or undefined. Undefined comes in when we have the function in the form of fraction or rational, right? But when it is a polynomial function, it's not divided by anything, then always think about the values of x that will make the function 0. But when you have it in the form of fraction, then two things happen. Is either you get value that will make the function 0 and undefined, or you can get only values that will make the function 0, or you can also get only values that will make the function undefined. Then you move to your line chart by putting the values on the number line and checking whether it is increasing or decreasing, positive or negative, and checking that if it is positive, minus, that is the maximum, and when it is coming with negative and positive, that is what is called the minimum, right? All right, so see you in the next video.